All right, so now in this section, we can talk about verifying trigonometric identities. So anytime when we want to verify an identity, we are checking to make sure, does the left-hand side equal the right-hand side? At no point inside there can we add or subtract across the equal sign. We have to think about each side as independent functions per se. Therefore, we cannot do anything across an equal side. Now, we can work directly with the left side, get to a certain point, and if we can't, if we think we're stuck, then we can come over here and work with the right-hand side to see if we can match them. But we cannot do anything across that equal sign. So just a little refresher on some of our identities that we can have. The first set is our reciprocal identities. Sine of x is equal to 1 over cosecant, which means cosecant is equal to 1 over sine x. Cosine x equals 1 over secant x, or secant x equals 1 over cosine x. Tangent of x is equal to 1 over cotangent of x, or cotangent of x equals 1 over tangent of x. So we're just kind of flipping them there. For our quotient identities, tangent of x equals sine of x over cosine of x. This one could become very important to us. And I say that in terms of, because if all else fails, we want to break everything back down to sine and cosine, so that one could come into play. Cotangent of x is equal to cosine of x over sine x. Next, we can have our Pythagorean identities. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. Even in odd identities, sometimes we play with these when proving, but in general, we don't. But we'll just do a little refresher. Sine of negative x equal to minus sine of x, because it's an odd function. Cosine of negative x is equal to cosine of x, because it's an even function. Tangent of negative x is equal to minus tangent of x, because it's an odd. Same thing with cosecant of negative x, that's equal to minus cosecant of x, because it's odd. Secant of negative x is equal to secant of x, because it's even, and cotangent of negative x equals minus cotan of x. So when we're seeing this, some of our big ones that we're going to consider are the reciprocal identities, along with the quotient identities and the Pythagorean identities. That's going to be the three main ones that we will focus in on. So our process, our guidelines for proving or verifying trigonometric identities. Like I said before, we want to work with each side of the equation independently of the other side. Start with the more complicated side and transform it in a step-by-step fashion until it looks exactly like the other side. Analyze the identity and look for opportunities to apply the fundamental identities. Try using one or more of the following techniques. The first one, rewrite the more complicated side in terms of sines and cosines. So in other words, break it all the way down to our basic two functions, sine and cosine. Factor out our greatest common factor if we have one. Separate a single term into multiple terms. So in other words, divide the denominator into each one of the numerators. Combine fractional expressions using the least common denominator. And then multiply the numerator and denominator by a binomial factor that appears on the other side of the identity. These are general techniques. Sometimes we'll use one of them, two of them, multiple ones, or we may only use a single one. It all just depends on what we're looking at it for the identity. Don't be afraid to stop and start over if you're not getting anywhere. If you think that you went down a rabbit hole over here and nothing is coming out that looks good, stop and start over, or start on the other side. Some of the most creative puzzle solvers know that strategies leading to dead ends often provide good problem-solving ideas because, therefore, you learned what not to do and what identities not to use inside there, or you may have applied an identity incorrectly. So all different types of things to look at. So our first example that we want to look at here. So when we look at this one right here, tangent of x times cosecant of x times cosine of x equals 1. First thing that I see in my head is we're going to work with the left side because it's the most complicated looking. I would actually apply the piece that told us to break everything down into sine and cosine. So we know that tangent is sine of x over cosine x. Cosecant of x is 1 over sine x. And then we have cosine x over 1. So what do we have here? Cosine x cancels. Sine x cancels. We're left with 1 over 1, which equals 1, which is what we were trying to prove, and therefore we're done. Not a lot of work here, it's just all algebra, really. So let's look at a little bit more complicated looking one right here. Secant of x minus secant of x sine squared x equals cosine x. Obviously, I'm going to work with the left-hand side. So I'm going to factor out a secant of x because they both have it in common. We know that 1 minus sine squared x is equal to cosine squared. We know that secant of x is the same as 1 over cosine x. And then we have our cosine squared x. So at this point, I can cross out a cosine x with 1 of the power. So this has left me with cosine x, which is the right-hand side. So let's look at this next example here. Cosine squared x minus sine squared x equals 2 cosine squared x minus 1. When I first look at this, the left side is where is what looks to something where I can start. And I say that because it's very similar to an identity that we already have. So cosine squared minus sine squared. Notice the right-hand side has a cosine squared, so I want to keep my cosine squared there. So what I'm going to do is I'm going to change sine squared into 1 minus cosine squared x. So we have our minus 1 and our plus cosine squared x, and we have a cosine squared x. Combining my like terms, I get 2 cosine squared x minus 1, which equals the right-hand side again. So, by looking at this one right here, tangent of theta times cotangent of theta is really tangent of theta times 1 over tangent of theta. They cancel out, leaving me with 1. So really, I'm left with 1 over cosecant of theta. But cosecant of theta is 1 over sine of theta. 1 divided by 1 over sine theta is just sine theta, which now matches what we were looking for. So for this next one here, we're going to have 1 minus sine squared theta over 1 plus cosine theta. I'm going to get a common denominator first so I'm going to multiply this 1 by 1 plus cosine theta over itself. So therefore I get 1 plus cosine theta minus sine squared theta over 1 plus cosine theta. So what my instinct says here is I'm going to replace the minus sine squared theta. So I get 1 plus cosine theta minus 1 plus cosine squared theta. So this equals cosine squared theta plus cosine theta over 1 plus cosine theta. Going to factor a cosine theta out of the numerator to get cosine theta plus 1 over the 1 plus cosine theta. But this equals cosine theta because cosine theta plus 1 and 1 plus cosine theta cancel. And we got what we were looking for of cosine theta. So for number 6 here, first thing I suggest, let's get a common denominator. So we would have cosine squared x by this multiplication plus 1 minus sine x times 1 minus sine x. This is all over cosine x times 1 minus sine x. So we need to FOIL out that numerator. So we get cosine squared x plus 1 minus 2 sine x plus sine squared x. If we combine cosine squared x and sine squared x, these two gives us 1. So we're left with 2 minus 2 sine x over cosine x times 1 minus sine x. We factor out a 2, we get 2 times 1 minus sine x over cosine x times 1 minus sine x. Canceling out the 1 minus sine x's, we're left with 2 over cosine x. Well, remember that 1 over cosine x is actually a secant. So 2 times 1 over cosine x is actually 2 secant x, which is what we were trying to get to. So for this next one here, it looks a little more complicated. Both sides look complicated. So what I would suggest doing in this case is, let's break everything back down to sine and cosine, and then we'll work with. So I'm going to work with the left-hand side first. So 1 over cosecant is 1 over sine x minus 1 over cosine x over 1 over sine x plus 1 over cosine x. I'm going to get rid of all my fractions in this case that are inside of a fraction. So I'm going to multiply everything by sine x cosine x over sine x cosine x. So that's going to give me cosine x minus sine x over cosine x plus sine x. There's not really much else we can do here to simplify this left-hand side. So what I'm going to do, I'm going to jump over here and I'm going to work with my right-hand side now. So cotangent of x is 1 over tangent. Tangent is sine over cosine. So this is going to be cosine x over sine x minus 1 over cosine x over sine x plus 1. So again here, I'm going to multiply everything by a sine x. So we get cosine x minus sine x over cosine x plus sine x. Left-hand side, right-hand side are equal. So there's some cases where we have to work with both sides. Sometimes we only got to work with one. It all just kind of depends on where we're at with everything and what we're given. So for this next one, cosine squared x plus 4 cosine x plus 4 over cosine x plus 2 equals 2 secant x plus 1 over secant x. So the first thing I want to do, I want to play with this left-hand side. This numerator factors. This becomes cosine x plus 2 all squared over cosine x plus 2. Canceling one of them out, we're left with cosine x plus 2 on my left-hand side. So let's think about this right-hand side now. So 2 secant x is 2 over cosine x plus 1 all over 1 over cosine x. We're going to multiply everything by cosine x. So I'm left with 2 plus cosine x over 1, which is exactly what we were looking for because the division by 1 doesn't matter. For number 9 here, tangent of x plus tangent of y over 1 minus tan x tan y equals sine x cosine y plus cosine x sine y over cosine x cosine y minus sine x sine y. I'm going to work with the left-hand side first. So this is sine x over cosine x plus sine y over cosine y all over 1 minus sine x cosine x sine y cosine y. So I'm going to multiply everything by cosine x cosine y. So when we do that, I get sine x cosine y plus sine y cosine x over cosine x cosine y minus sine x sine y. And that's what we were looking for. So sometimes it's the complicated may just be like one step, just depending on what we're looking for. So there's a couple different ways that we can try this one. We can either break it back down into sines and cosines, or we can leave it and see what we end up here. I like the sine and cosine way. So this becomes sine squared x over cosine squared x plus 1. And then we have our cosine squared x plus 1. My right-hand side would be, we'll leave the right-hand side alone for now. I don't like playing with both of them at the same time. So when we FOIL this out, we get sine squared x plus sine squared x over cosine squared x plus cosine squared x plus 1. Sine squared x plus cosine squared x gives me a plus 1. We already have our plus 1 right here. Sine squared x over cosine squared x is really just tangent squared x. So we end up with tangent squared x plus 2. And that's what we were looking for on the right-hand side. So we've seen several different variations. We've seen basically 10 problems, which all of them have kind of worked in different ways and everything. We factored stuff out. We FOILed. We've multiplied by common denominators and everything. So lots of different ways to look at different problems and everything. So just some nice examples to be aware of here.